Okay, so in this video, we're going to talk about speed and velocity, and then we're going to get into talking about motion that has constant velocity in it. Okay, so in the last video, we talked about distance and displacement and the different units we're going to be using in this class. We're going to be using meters and seconds and meters per second, and all of that stuff. And then we talked about distance and displacement. Okay, so just to recap, distance, when you're talking about an object that's moving, the distance it travels is literally how far that object has moved. Displacement of an object has to do with how far is the object from its starting point. In other words, what is the difference between the final position and the starting position of the object? Okay, that's what displacement is. Now, speed and velocity sound like similar things, but they're actually two separate things. Okay, and so in simple terms, velocity has direction, speed does not. Okay, in simple terms, that's basically the difference between speed and velocity. So, for example, if I tell you I'm in my car traveling 45 miles per hour, I've told you my speed. Okay, 45 miles per hour tells you how fast you're going, but it doesn't have direction. If I say I'm traveling 45 miles per hour north, that is my velocity, because not only does it have my speed, it also has a direction. Okay, so velocity has direction, speed does not. Okay, speed is distance over time. Okay, so speed is distance over time. And then velocity is displacement over time. And again, this is just the most simplistic way of explaining this. I could go into more detail, but it's not really important for what we're doing now. Okay, so in simple terms, velocity has direction and speed does not. Speed is distance over time. Velocity is displacement over time. Okay, so keep in mind that the definitions of distance, displacement, speed, and velocity as we take a look at example 0.5. Okay, so example 0.5 says a boy walks from his home, so he starts at home, to the store, and then back. Okay, so he starts off here, he goes to the store, and then he goes back. It takes the boy 2 hours to complete his trip. Now, we're going to see this later on in this video, okay, but I have just found a given piece of information. And so I'm going to underline that, 2 hours, and I'm going to label that. Okay, I'm going to write t because it's a time. I'm going to write t equals 2 hours. And you might ask the question, how do I know to label that t? How do I know 2 hours is time? Well, it's based off of the unit. And if you look at the unit, what do you measure in hours? That's time. If it said, 2 seconds, that would also be time because second is a unit for time. Okay, if it said meters, that would probably be distance or displacement. Okay, so you can look at the unit as a context clue to tell you how to label something. So I'm going to write t equals 2 hours. And the question says calculate the average speed of the boy, and then calculate the average velocity of the boy. Now remember, velocity has direction and speed does not, but also speed, I'm going to write S for speed. Speed is distance over time, and velocity, I'm going to write V for velocity, is displacement over time. And remember, the way you do displacement is you write delta x, and that represents displacement. Okay, so let's use the picture to answer the question. If I want to find the average speed of the boy, I need to find what distance did the boy travel. So if you look at the picture, it's 3 kilometers, km is for kilometers, from his home to the store. So if he goes 3 kilometers to the store and then 3 kilometers back, that means the total distance he's traveled is, this is S for speed, is 6 kilometers. Okay, so that's the distance, and if I divide by time, I'll have the boy's average speed. So 6 kilometers divided by the time, which is 2 hours, gives an average speed of 6 divided by 2, which is 3, and then kilometers over hours is kilometers per hour. Okay, so 3 kilometers per hour is the boy's speed. Now, what is the boy's average velocity? Well, again, to find velocity, velocity is displacement over time, so delta x over t. okay, displacement over time. And if he starts at home, goes to the store, and then goes back, remember displacement is the difference between the starting position and the ending position. Well, if he ends up back where he started, that means his displacement, that means his delta x is going to be 0. So the time is still 2 hours, right? But 0 divided by anything is 0. So his average velocity would be 0 kilometers per hour. Okay, so even though he's been moving this whole time, his average velocity is 0 because he ends up back where he started. Okay, so key takeaways is that speed and velocity are similar, but velocity has direction and speed does not. And then speed is distance over time, velocity is displacement over time. Okay, so pause it there if you need to write any of that down. Remember, as we're going through these notes, you should be writing down key information in your notes. I would suggest that you take handwritten notes. As we go through examples, I would definitely write out all the work I show in the correct order, so that when you're working on problems on your own, you understand the process in going through and solving the problem. Okay, so I'm going to erase this. Okay, this slide just kind of summarizes what speed and velocity are. Okay, so the symbol for speed is S, the symbol for velocity is V. The vast majority of the time we're going to be dealing with velocity. Okay, but so you're not going to see speed too often. We're mainly going to do everything with velocity, just to make things easier. Okay, and velocity can be in miles per hour, feet per second, meters per second is what you're going to see most often. Okay, so meters per second, the way you write meters per second is m/s, and that's meters per second. The slash means divide, and when you divide, you say per. Okay, so meters per second, not miles, meters per second. Now, we're going to be looking at starting to solve problems with motion, and so what we're going to do now is we're going to start with the very simplest type of motion. So think about how an object can move. Okay, imagine any object moving. Think about the simplest possible way something could move. Okay, the simplest possible way something could move is with what's called constant velocity. Okay, so we're going to start off in this unit talking about constant velocity. So pause it here if you need to add this to your notes. Now the two most common types of motion we're going to see in this class are constant velocity and constant acceleration, which we're going to talk about that in the next unit actually. Okay, now what does that mean, constant velocity? Well, constant means not changing. And so when you talk about constant velocity, you're basically talking about an object that's moving, and it's not moving any faster, it's not moving any slower. Okay, it's not speeding up, it's not slowing down, and it's just moving forward or backwards in a straight line. Okay, that is motion with constant velocity. Okay, so for example, if you've ever driven in a car and you turn on the cruise control. Cruise control is where you hit the button and then the car kind of keeps going at the same speed, and you can take your foot off the gas pedal and it'll keep going. That's what cruise control is. Okay, that's an example of constant velocity. You're not moving any faster or slower, you're just going at a steady pace in a straight line. Okay, now we're going to see a lot of equations this year in physics. Okay, and so this equation I'm about to write down is one of the most basic. This equation I'm about to write down only applies for constant velocity. Here is the equation. Delta x equals v times t. And again, this only applies if you have constant velocity. So we're going to use this equation a lot in this unit because this is a constant velocity unit. In the next unit, when we talk about acceleration, we're not going to use this equation so much anymore because this equation only applies for constant velocity. So what does this equation say in words? Think about what is delta x, what is v, and what is t. Okay, well, what this equation says is that the displacement of an object, if it's moving at constant velocity, is equal to the velocity of the object times the time that the object is moving for. Okay, and so what we're going to do now is we're going to solve some problems using the constant velocity equation. Later on, we're going to look at solving constant velocity problems with graphs rather than equations. Okay, so make sure you write that equation down and add this to your notes. I also want to remind you, okay, so this is displacement. Delta x is displacement. What is v? V is velocity. and then t, of course, is time. And I want to remind you about the units for these things. Remember, displacement in this class is typically measured in meters. Velocity is typically measured in meters per second. And then time is typically measured in seconds. Okay, and those are not the only units for those things, but they're the most common units. Okay, so make sure you write all that down. Okay, pause it there if you need to finish writing. Okay, so we talked about the example of cruise control before. If I pull up the simulation, I can show you what that might look like. Okay, so this simulation is called the moving man. And what I'm going to do is I'm going to give him a constant velocity of 2 meters per second. And when I hit play, you're going to see how he's going to move. His velocity is 2 meters per second. So every 1 second, he's going to move 2 meters to the right. Notice how he's not moving any faster or slower. He's just going at a steady pace. Now, what if I give him a velocity of negative 2 meters per second? So remember, velocity has direction. So if it's negative 2 meters per second, guess which way he's going to move? He's going to move in the negative direction. Okay, so you can have negative velocity or positive velocity, and that just tells you what direction the object is moving in. Okay, but again, he's not moving any faster or slower. He's just moving to the left at 2 meters per second. Okay, so that's kind of what it would look like if I make it positive 5 meters per second. Notice he's still not moving faster or slower, but now he's not speeding up or slowing down, but he is moving faster than he was before, and then he goes off the screen. So that's kind of what constant velocity would look like. Okay, so make sure you have this equation written down. We're going to look at solving some very basic problems, and we're going to use what's called the guess method of problem solving. Okay, so pause here and write this down in your notes. Okay, the guess method for solving problems is basically a way of breaking down a problem and making it easy to work through the problem. Okay, so here's how you use guess. Okay, the G stands for given. That basically means you look at the problem, you underline or you highlight, and you write down the information given to you in the problem. Okay, the way you do that, we saw before, look at units, look at context clues in the problem. Okay, identify what's given. Then identify the unknown, that's the U. Write down what the question is asking you to find. Then E is for equation. You write down the equation that you need to solve the problem. Now, right now, that's very easy because the only equation we have is constant velocity, that delta x equals v times t. So we only have the one equation right now, so that part's easy for now. Then you're going to substitute. That means you're going to plug in numbers into the equation. When you plug in, you don't need to plug in units. In fact, I would highly recommend that you don't plug units into the equation. And then once you plug in, you're going to solve. Now, in order to solve, you're going to have to use the skills that you learned in your math class and algebra. Okay, remember all those times you had to solve for x? You're going to have to do that to solve a lot of these equations. Okay, that basically means rearranging the equation and getting your unknown by itself. Now, the way we're going to do that is basically we're going to use math operations to undo everything that's being done to the unknown variable. And the way I teach that is to use reverse PEMDAS to undo operations in the correct order. So you should have learned about PEMDAS in math classes in middle school. PEMDAS is for order of operations. Okay, so that stands for parentheses, exponents, multiply, divide, add, and subtract. To solve an equation and rearrange the equation to get the unknown by itself, you're basically going to do PEMDAS backwards. And I'll do lots of examples to show you what that looks like. But basically what we're going to be doing is we're going to be using opposite math operations to undo what's being done to the unknown variable. Let's look at a simple example. Okay, so a bunny hops along at 0.35 meters per second. How far will the bunny travel in 4 seconds? Okay, so the first thing I do is I underline anything with numbers. And then I look at the unit, meters per second. Think to yourself, what has units of meters per second? The only thing we've seen that has meters per second as a unit is velocity. So I'm going to label that as v. Then I see something else that has units, 4 seconds. Okay, what is measured in seconds? Well, that's time. Now the question says how far. Questions about how far or how high are always going to be about displacement. Okay, so if you have a question about how far something traveled, that's always going to be about displacement. Okay, so this is my unknown. So if I'm using guess to solve the problem, what I'm writing down is v equals 0.35 meters per second and t equals 4 seconds. That's my given. What is my unknown? Delta x. Because it asked me how far the bunny travels. That's what I'm solving for. What is my equation? Again, I only have one equation right now. Delta x equals v times t. Okay, so I write down my equation, and then I substitute. That means plug in. Okay, so I take my equation. Delta x equals v times t. And I plug in. Now, I don't know what delta x is. That's my unknown. And so I just leave that alone for now, and I write down delta x. I do know what v is. V is 0.35. And I do know what t is. T is 4 seconds. Notice how I'm not plugging units into the equation. Now the last step is to solve. Delta x equals 0.35 times 4. You can use a calculator if you want. Okay, but if you multiply that in a calculator, you should get 1.4. And then what is the unit for displacement? That's going to be meters. Okay, so you have now solved your first physics problem. That is a very simple example using constant acceleration. Okay, and we use the guess method to just break down the problem and make sure we're solving everything in the correct order. Pause it there if you need to write that down, which I would highly recommend that you do. Okay, so I'm going to erase. Again, pause it if you need to look at that some more. Okay, this slide basically has the exact same things, just typed out instead of written out. Let's do a few more quick examples, and then you can work on your practice assignment. Okay, example 2. A boat travels down a river. If it moves at a steady pace, think about what that means, steady pace. What word have we been using to refer to something that moves at a steady pace? What type of motion have we been talking about? Well, hopefully you said constant velocity. So this is a clue telling this that, hey, this is a constant velocity problem. Why is that important? Because the equation for constant velocity is delta x equals v times t. So they're telling us, hey, you should be using that equation. Now, as I go through, again, I'm looking for numbers because that's going to be my given. Or that's going to, that's going to be my given information. 60 kilometers. So think about what a kilometer is. It's like a unit of distance or a unit of displacement. So based on the unit, I'm going to say, hey, that is going to be delta x. Okay, again, just looking at the unit. Same thing right here, 3 hours. What do you think I'm going to label that as? Okay, what's measured in hours? That's going to be time. So I write down my given. Delta x equals 60 kilometers. T equals 3 hours. What is my unknown? Okay, so I'm using guess here. I got my g. I need to find what is the question asked me to find. Well, it tells me to calculate the velocity. So that's my unknown. V equals question mark. What equation should I be using? Again, we only have the one equation for right now. Okay, so I'm using the constant velocity equation. And then I want to substitute and solve. Now, when you substitute, remember that means plug in. Delta x is 60. So I'm going to put in 60 for delta x. I put the equal sign. Always make sure you have an equal sign in your equation. I don't know what v is, so I just leave that in there. And then I plug in for t. T is 3. Now, when we're going to solve, we're going to have to use basic algebra skills. So here's how you do this. We have the equation 60 equals v times 3. What you want to do is ask yourself, what is being done to my variable? What is being done to v? Okay, the answer is v is being multiplied by 3. Now remember that we want to undo anything that's being done to the variable. What is the opposite of multiply? What is the opposite of multiplied by 3? Okay, hopefully you said divide by 3. And so what I'm going to do is I'm going to divide by 3. Okay, but the rules of algebra say if you do something to one side of the equation, you have to do it to the other side as well. So I'm going to divide both sides by 3. 3 divided by 3 cancels, and now I have v by itself. Okay, so v equals 60 divided by 3, which is 20. The unit for that is going to be kilometers per hour. Okay, so again, all I did was plug in, and then to get v by itself, I asked myself what's being done to v, what's being done to my unknown variable, and then I undid that thing. Okay, it was being multiplied by 3, so I had to divide by 3 on both sides. Okay, pause it there and add that to your notes. Okay, I'm going to erase this. Okay, so on your own, I want you to try to answer this question. Okay, so pause it here, work out the problem on your own. I'm going to write down the equation just so you have it. Try to use the guess method and see what you can come up with. Okay, so answer this question on your own. Okay, so hopefully you got the correct answer. Let's find out. We know it's constant velocity, so that tells me, hey, I'm using this equation. 3,500 meters based off of the unit. I know that's delta x, that's displacement, because that's how far the race car traveled. 60 seconds is going to be time. And then my unknown is going to be velocity. So I'm using guess. G, my given, is going to be delta x equals 3,500 meters. T equals 60 seconds. My unknown is going to be v. My equation I already have up here. And then I'm going to substitute and solve. So I'm going to plug in delta x, I'm going to replace with 3,500 equals, v is unknown, so I just leave that in the equation, and then t is 60. I ask myself, hey, what's being done to v? I want to solve for v. What's being done to v? It's being multiplied by 60, and the opposite of multiply is divide. So I'm going to divide both sides by 60. And so in my calculator, I'm going to type in 3,500 divided by 60. Okay, now you're going to get a decimal answer. Okay, you don't need to write down all of the decimals. I'm only going to write down one. So I'm going to write down 58.3, and then the units are going to be meters per second. If you want to know how I know what the units are, if it's 3,500 meters divided by 60 seconds, it's going to be meters per second. Okay, so that is the answer to example 3. So hopefully you got that. Pause it there and add that to your notes. Okay. Now, if you want extra practice, here's example 4, and I'm not going to work through it because I want you to try to do it on your own, but I will tell you the answer that you should get if you want to do this extra practice. The answer is going to be 30 seconds. Okay, that's the answer to example 4. So if you want the extra practice, if you don't feel confident, try to do example 4 on your own, and then this way you can check to see if you did it correctly. Okay, so what you're going to do now is you're going to work on practice problems over constant velocity. As always, please let me know if you have any questions, and I will see you guys in the next video.